Hey there! I'm Chroma, and today I will be teaching you how to make a character jump in Unity. We will cover jumping, both high and low, depending on how long the user holds the jump button. As well, we will cover ground detection for determining whether or not our player can currently jump. This tutorial is sort of a continuation of a recent tutorial I did covering player movement, so while it will be basic and hopefully easy to follow, we will be sort of skimming over some of the topics discussed in that video, as to not have to re-explain things for people watching both. So, without further ado, let's get started! Alright, so to start off, let's open up a new Unity project. And then to begin setting up our player and ground, we'll do just that. Make our floor and player objects. So going into the hierarchy, we'll first create a cube for our floor and rename it as such. Then let's move it to the center of the world by resetting its transform component. And then to make it more floor-like, let's squish it on the y-axis of its scale. And then let's scale it up on the x and z axis. And there we go. That looks like floor to me. So now let's make our player by creating another cube and rename that to player. Then let's move this to the center of our world as well. And then let's just drag it up a bit. That looks good to me. So then when we have gravity and all that, we can see that our player is falling like we want it to. So let's now, first, before we get into actually making our character jump, let's give some color to our scene, just to make it look a bit nicer. So let's first make a folder in our assets window here called materials to store our colors, and then going into that, let's make a material for first our floor, and then we can go and recolor that to a cyan color, again, because why not? So then let's make another material that we will call player, and we will rename, or we will recolor this to red. Again, just random color choices here. So now we can go and drag our materials onto our floor and player, and ta-da, we have some color. Lastly, before we get to actually making our player fall and jump, let's just put our camera into a better position to view our game. So first I'm gonna have it sort of be angled down by 10, and I can go into the game view so we can actually see what we're looking at here, and then -45, and then let's move the camera so it kind of, is viewing our scene kind of on an angle. Let's go -8, 8, and 5. Sure, that looks good. Perfect, so now we have our basic scene set up, so let's get our player jumping. So, so the first thing that we're gonna wanna do is, the way that we're going to be getting our player to jump is using Unity's built-in physics engine. So to allow our cube to act under physics, we're going to be adding a component to it called a rigid body. So ta-da. And by extension, if we were making jumping for a 2D game, you could add a similar component called a rigid body 2D, and most of the stuff we will be covering should be pretty much the same. So now we will also want to use gravity to be checked, as we are going to want gravity to affect our player. And then for the purposes of this tutorial, so that when we're making our cube jump, it's not moving in any other directions, we're just going to freeze rotation on every axis and then freeze position on X and Z. If you had your own movement system for, if this was a character that can move and jump, you'd probably be dealing with your own way of how you're getting the character to move. But in this case, we're not doing any of that. We're just getting it to jump. So we're just going to freeze all those axes. So it's just moving up and down. Perfect. So now, onto the actual jumping, we're going to be doing some coding. So let's first create a folder to store our code that we will call scripts. And going into that, we will make our first script that we will call, making here, player jump. All right, waiting a second for that to compile. Let's now open it up in Visual Studios. All right, so here we are. Now to get started with having our player jump, we're going to want to get a reference to that rigid body component that we made so that we can apply forces to it. So we can go private rigid body, or rigid body 2D if you're making a 2D game. And then we can call it just RB. That works, I suppose. And then getting that variable in our start function, we can go RB equals get component rigid body. Perfect. There we go. So now in our update function here, we're going to want to test if the player hits the jump button, and then if they do, make them jump. So let's first get that keyboard input by going if input dot get key down here, and we're specifically going to use get key down because we want to have this run only on the frame when the user presses the jump button. If you wanted to have, I guess, continuous jumping, you could use just .get key, and then you could hold it down and the player would keep jumping as they touch the floor again when we get ground detection to be working. So input.get key down, and then we want, we're going to use the space key as our jump key. So then we can use keycode.space, and that would be getting input from the space bar, and then brackets here. And now over here. So now if they press the space key, this code will run. So here we now want to apply force to our player. So we can do that by getting our rigid body and going rb.add force. Very similar to what we did with moving our player in that other tutorial. So now the actual force we will be applying will be, first we need a direction, which will be vector3.up, the up direction of in our world to make our player go up, basically, and then multiplying that by a force. We are actually going to go up here, and just to make things easier in the to modify in the editor, we'll make a new public variable that'll be a float, so a decimal basically, and then we'll call that jump force, I guess. Yeah, and then just multiplying vector3.up by jump force. And because I already know that this value is going to need to be pretty high for it to work, I'm just going to also add a times 10, just so the variable in the inspector doesn't need to be as high. As well, so with the way that add force works, if we were to apply it like this, it's going to be, this implementation is meant to be sort of for if you were adding force over a continuous period of time. So like moving a player, or like wind, or as a better example, so like wind, something like that. Here we want to apply basically an instantaneous force. So we're actually going to need to make a slight modification, I guess, to how we apply this force. So if we add a comma, we have an additional set of thing as input that we can pass to add force, and that's a force mode. And as well, there's force mode 2D for 2D related rigid body jumping stuff. So then we have a few options here: force mode dot acceleration, force, impulse, and velocity change. By default, if you don't have anything, force mode dot force, I believe, is the default. Yeah, so that's that. We will be changing it to impulse, so it'll be more of an explosion force, sort of launching us up into the air. And yeah, so we basically have that. So now saving this and going back to Unity, let's first add this script to our player and go into play mode. Nope, wait, let's first 2, let's try 2, which will actually be 20, sort of, if we are multiplying it by 10 as we did in our code. So let's set that as our jump force and go into play mode and see what that's looking like. So starting off, we notice that we fall, but we fall quite slowly. We will be dealing with that in a moment. So now, okay, we jump really high, but it works functionally. So now if we hit the space key, we successfully jump just really, really high. Now, one thing that would be a problem is every time you hit the jump button, you're going to get launched into the air. So we're going to want to deal with that. So let's deciding the order I want to do things. Actually, no, before we do that, I'd like to deal with that falling gravity situation. So you may notice that, yeah, gravity was kind of, we were falling quite slowly. So that's something that we might want to increase. Now, one thing that we can do to deal with that is going up to Edit and Project Settings. If we go down to Physics or Physics 2D, we have one option here called Gravity that is by default set to -9.81, mimicking real-life gravity. So if you want the player to fall faster, one thing that you could do is increase this number, or decrease to make it a larger negative number to go in the down direction, to make the object fall faster. However, this is not what we will be doing, because this is this gravity applies to any object in the scene that uses a rigid body. So if you had a bunch of objects that have physics acting on them, increasing gravity for just our player will increase gravity for everything, and that might not be what we want. It could lead to, like, if everything's falling way faster than it should, or than you'd want it to, it could be problematic. We will basically be adding our own gravity on top of the gravity that's already being applied. So we will do that by making a new public float called, let's go gravity multiplier. There we go. And then every frame, we're just going to apply this additional gravity force in the downwards direction. So I'm going to first copy our one line here for rigidbody.addForce. And then we're actually going to make a new function called fixed update. And this is a predefined function that exists in Unity, similar to the normal update function, except this is better for dealing with physics stuff in that it'll run more consistently with dealing with physics stuff. Now, the reason why we didn't put this line in fixed update is because of the way that Unity handles input related stuff. It's generally better to get input, so like the space key, mainly for like dot key down or dot key up, not so much just the normal get key. It's better to get that stuff in normal update, because sometimes if you have a get key down thing in fixed update, you can have problems with not getting that input, and it can be a little spotty, I suppose. So it's generally better to get input in the normal update function if it's dot key down or get key up. If it's just the normal get key, then it should be fine. Now, so as well, the actual force that we're applying, this is only a one-time force. Like, we're only applying this once when we hit the space key to jump, so it's fine that we're only applying it like once in update. For something down here with our gravity multiplier that we'll do in just a second, that's going to be something that's going to be applied every frame, and thus we'll want it to be consistent with how it's applying that gravity. So down here, we're going to have rigidbody.addForce. We can use vector3.down, which is just the negative of vector3.up, and then instead multiply this by gravity multiplier. And we will not make this an impulse force, so we'll delete that there. So ta-da. Now we have that in a second. Now we have this gravity multiplier. Now we'll fall faster. So cool, we have that. So now let's deal with getting our player to only jump when we're actually on the ground. Actually, as a default value, I don't know, I'll put 2, I guess. We'll deal with the actual values when we have more of an end product. So now let's get our player to actually only jump when we're touching ground. So we want to, first make sure that we're actually touching ground, and it's only the bottom of the player that's touching ground, and be able to discern not just any object that we're colliding with, but what is ground and what is not, with whatever the context of our game. So first, going to our floor here, how we will be testing whether something is ground or not, or some sort of environment that we can jump off of, is we can go up to the layer thing here, and we have a few different layers here: default, water, UI, stuff like that. We can click add layer and be brought to this fancy menu here. So we can make a new layer that we will call environment, and then anything that is on this environment layer we can set as is jumpable. Like, we can jump off anything on, in this case, layer 8. So yeah, so going back to our floor, that didn't actually set the layer. It brought us to the thing to create new layers, but it didn't actually change the layer that our floor was on. So now we can see that we have a new environment layer here, so we can change our floor to be on that environment layer. Cool. Next, let's so with our player, in terms of colliding with ground, we want to make sure that's only the bottom of the player that's touching this ground to jump off of, and not just like walls or ceilings. So we're actually going to make a new empty game object that's going to be a child object of the player, and we will rename this to ground detection. Cool. So yeah, so now this is an empty game object that's within the player. We can move it down to, and actually I can go into a perspective view to better see this. We can move this down to like right near the bottom of the player at what looks to be, for our cube here, negative 0.5, and then we can add a box collider with the purposes of this character. Could be a different type of collider depending on what you're dealing with whatever game you're making. So now we have an additional box collider here. Let's decrease this size to 0.1 is good. It's also good to have a bit of a buffer sort of area between like where the bottom of our player is, slightly below that. And then as well, the X and Y part of that, we're going to make 0.9, just so, again, if we were touching walls, that's not going to be touching this sort of cube we have here. Lastly, we're going to make it a trigger. So basically, nothing will actually be colliding with this. It'll only be used to be able to run stuff in code of things touching this cube, but there won't be actual collisions with this object here. So now we have this ground detection empty game object here. Now let's make it actually work the way we want it to with code. So we're going to make a new script that's going to go on this player, this ground detection. So we can create a new script here, and we can call it player ground check, I suppose. Now wait for that to open up. Now this is going to go coincide with our player jump. We're basically going to need a variable that's like that's a boolean of whether or not we are currently on the ground. So how we're going to deal with doing that is we're going to make a variable here that is a boolean called, let's call it is grounded. Now, in order to, we don't really want this to appear in the inspector, but we do want our player jump script to be able to access it. So the way that we can get around that is we can make it public, and then to make it so it doesn't show up in the inspector, we can, in square brackets, type hide in inspector. So yeah, we can do that, and then now it won't show up in the inspector, but other scripts can access it because it's public. So now we haven't actually done anything to set this yet, but back in our player jump, how we will be using this once it's then working is down at our where we're getting input for the space key. We can just add, actually, well, no, sorry. First we need to actually get the reference to that player ground check script, and we can do that by making a new public variable that we will call play, or that's of type player ground check, the type of that script, and then we can call it just player ground checked. Simple as that, except with a lowercase first letter, so it's an actually a different name than the type that it is. So now we'll need to get that reference in our start function, so we can type player ground check, and case matters in this case, of having capitals or not capitals where they should be. So then in a very similar manner to how we dealt with our rigid body, we can then use get component player ground check. Ta-da. All right, so now that we have that, we can then go down to our update function, and we can use player ground check dot is grounded, and we have our variable here that we made in the other script. So we want to test if both of these are true. So we have player ground check dot is grounded, and then with a double and sign, we can basically then have, if this is true, the is grounded, and we've hit space, then run this code. As well, if you wanted to, you can also have or with two of, I don't know what this character is called, but two of these symbols. So yeah, but in this case, we're using and. So we have that now. So now we need to actually make that is grounded check work properly, because at the moment it's not being set in any way. So we are going to get rid of both our start and update functions. And now, remembering that this script is going to be on that trigger collider, we can use a special function that Unity has called, so of type void, on trigger enter down here, and on trigger enter 2D for if you're dealing with a 2D game. So using on trigger enter, and it automatically has a input of type collider called other. That's going to be a reference to the thing that we collided with. So in this case, it could be the ground, or it could not be. Maybe it's a wall or an enemy or something that we don't want to set is grounded to true. So we're going to have an if statement of if this thing that we collided with, so other, and if this thing is on the ground, or the environment layer, and we can get that by, so this is a type collider, we can use game object to get its game object, the game object of the thing that we just collided with, and we can use .layer. Now, if you remember, that environment layer was on layer 8, so we can just test if this layer is equal to 8, meaning it's on that environment layer. Then we can set is grounded equals true. Ta-da. Now we want to do then the opposite for if we leave ground. So we can not copy this, but we can make a new function, void on trigger exit, that is basically the same thing, but when we leave the collider of something, so then we can copy this code down here. So if the thing that we just left was on layer 8, then we can set is grounded to false. And it's as simple as that. Now, for a platformer or something similar, one thing you might want to consider doing to have better jumping sort of stuff if you want it is when the player leaves ground, leaves the surface. So going back to Unity for just a moment. So in like the split second when they like leave a platform, you might want for a split second for them to still be able to jump. A lot of good platformers have that as sort of a feature. So what you might want to do is sort of add a delay using a coroutine of when they leave ground to wait like 0.2 seconds and then disable that is grounded and thus not being able to jump. And that could be a good idea there. For this simplistic tutorial, we're not going to cover that here, but just an idea. Maybe that'll be my challenge to have make that a feature of having that sort of delayed jump. Anyways, so now already, actually, I can go back to Unity again. We can go into we need to actually put the script on our player. And actually, because it's a child object, one thing I forgot to do over here, we can't just use the normal get component because this script that we're getting a reference to is not on this object, the same object that the player jump is on. It's on a child object. So we can instead use just get component in children, and that should work. So now having that, now we can go into play mode, and we should see, perfect. So now we have, and we can see both our gravity multipliers working as well. So now if we hit the space key, we are jumping, we are falling a bit faster, and if I spam the space key, we are only jumping if we're actually on the ground. So that's pretty cool. Now, I would like to cover one additional thing that, again, can be good for platformers, which is with jumping, it's not always enough to just have, like, you press the space bar and you jump a fixed height. What if we wanted to have jumping at different heights depending on how long you hold the jump button? Yeah, let's do that, just that. So how we actually are going to cover that, or make that possible, is we are first going to make two public variables here. One called fall multiplier, and another called, or another public float called low jump if I can spell, multiplier. So the logic here of how we're going to fall faster or slower depending on us holding the jump button is we can get the velocity, the y component of the velocity of whether our, so we can get the y component of our velocity and then test if it's greater than 0, if we're moving up, then we can test whether or not we're still holding the space key. If we let go of the space key while we're moving up, then we can apply more force to get us to fall faster, so then we thus have a lower jump. Otherwise, if we're still holding the space key as we're moving up, then we don't apply this additional force. So let's go and code doing just that. Another thing we can do down here first, just to make things a bit cleaner, is we can put some of this code in its own functions. So let's first make a function called jump, and below that another function called fall. Cool. And then now this code for our jumping up here, I'm just going to copy that and paste that here, delete it, update, and then just replace it with calling this jump function. And then here, this increased gravity is affected by our falling. So I'm going to put it down here and then call this fall function. So that's just a bit cleaner and it's a bit easier organized to tell what code is doing what. So you can see that this is the jump code, this is the fall code, etc. So now the code we're going to be using to fall faster or slower is kind of part of our fall routine. So let's add it to this function. So first thing we're going to want to do is we're not going to be doing any of this falling if we're not grounded, because we don't really need to. So we're going to first, having this reference to is grounded, I can actually copy this here and paste it there. We're going to test whether or not we are currently grounded. So if we're not grounded, having an exclamation mark in front of it to mean not. So if we're not grounded, then we're going to fall with our gravity multiplier and all that. But now in front of all that, we're going to deal with whether or not we should be falling faster or slower, depending on the jump button being held. So we're going to test if our rigid body dot getting the velocity and then getting just specifically the y component of that velocity, which is our up-down motion. So if that velocity is greater than, if it's greater than or equal to 0, meaning that we're moving up, and the same and symbol that we used up here, and we're currently holding the jump button, so we can copy this input code and paste it down here, and then get rid of the word down. So we are using .getKey. So if we were moving up and we are currently holding the spacebar, then we are going to want to, actually no, if we're not holding the spacebar, so if we're moving up and we're not holding the space key, then we're going to want to apply an additional force to make us move down. And we can do that by, we can copy our gravity multiplier code here. A lot of copy and pasting, but we're changing stuff, so it's not necessarily a repeating code, just copying certain parts, not to retype things out. So then we can apply this force in vector 3.down using our low jump multiplier, and then we have that. Otherwise, hold on. Otherwise, as well in an if statement, if rigid body dot velocity is less than 0, so if we are moving, or just the y component as well, so if the y component of this velocity is less than 0, so we're moving down, we're going to apply another additional force to fall faster. That is going to be the same thing, but just using our fall multiplier. And then this is kind of like our gravity multiplier in terms of falling faster. This is only going to take place if we are moving down. So we fall faster, but when we're going up, we're not losing that speed going up. And that'll allow us to have more, crisp jumping of going up slowly and then falling faster. So now, having that all in place, if we go into Unity, we now have all these values here. And now I'm quickly just going to check my completed project here just to see what values I put in here. So 3, 20, 1, and 9. Except actually I made these variables in different orders, so I have to know which is which. So a lot of this was just testing and kind of trial and error sort of thing. But just plugging in these values here. The fall multiplier is 2, and no, yes. So having this as 1 and that as 20. So now hopefully, if everything works as it should, going into our scene here, we can now, there we go. So we can press the space key and jump as before. As you can see, holding the space key, we go up sort of fast. We kind of pause at the top and then like fall. And it's very, snappy, which can be good for a platformer. As well, if we just tap the space bar, as soon as we are letting go of the space bar, we are falling faster. And as well, at any sort of middle height, we are falling faster or slower depending on when in our jump we let go of the space bar. So yeah, that's pretty cool. And now we have a player that can jump. We can jump high and low. We can determine whether or not we can currently jump depending on the surfaces we are interacting with. And yeah, the tools are basically in place so that I challenge you to combine this setup with jumping either in 3D or 2D with the player movement stuff to make it basically a platforming character thing setup, whatever you want to call it, either in third person or first person. Be creative, I suppose. As well, I'd like to see if you could try and implement what I said earlier of having a sort of delay of when you exit a platform or ground that you basically become not able to jump after a certain delay. Delays are something I've covered before, so all the pieces are in place. So that is my challenge. See what you can do with it, and maybe going an extra step to make it more creative and unique in whatever way you wish. So I hope you found this tutorial helpful. If you have ideas for tutorials that you want to see, please suggest them in the comments below. Thank you all so much for watching, and as always, I'll see you around.